Hello and welcome to our video on a surface area introduction and also how to find the surface area of prisms. Surface area is the area around the outside of a three-dimensional shape. So it's this outside area. Where we use this in real life, it can be used to help calculate the amount of paint if we were to cover this shape in paint, so how much paint we would need, or the amount of wrapping paper if we were to wrap up this shape in total. One of the terms we're going to use is total surface area, which we'll refer to as TSA, and it's found by adding up the areas of all the shapes that make up each face of the object. In a square-based prism, just like the one I've got here, each side or each face is a two-dimensional rectangle. So if you look at this top side here and take it out into two dimensions, it would be a rectangle. If we look at this side facing us and take it out, would be a rectangle as well. So we're talking about all those outside faces. If we look at this side, on the left hand side, that one in this example would be a square. But there's some other sides that we can't really see that are in behind, and there's the base, the very bottom, which is hard to see. So we need to make sure we're covering all of the sides and finding the area of each of the shapes that make up each side. I've put it here, each of the ends is a square. There's my example. A square here and a square on this side as well. Something interesting that happens when we look at the faces on a prism, and it's interesting to note here, is that opposite faces are always the same shape. So if you look at the top here that I've drawn up here, and imagine the very bottom of a cube, then they're going to be the same shape. If you look at the left hand side and the right hand side, they're both going to be squares. When we're trying to find out the total surface area, it can be useful to use a net to make sure that you're not missing any sides, because it can be hard to look at a diagram and see all of the sides properly. So if you're looking at the net of a square-based pyramid, you'll have the two squares on each side. I'm drawing this freehand. Would normally be straight sides. You'd have two square sides and then four of these rectangular sides to make up the four sides going around the square. If we look at a more complicated prism, I've got here a triangular based prism. It doesn't matter that it looks tall rather than long, but when you have a triangular based prism, you end up with two triangular sides. In this example, it's the top and the bottom, and three rectangular sides. So the net would look something like this. See how this side's a rectangle? And the two slanting sides will be rectangles as well. So I'll draw one of my rectangles, put my triangle on there. This time I'm only going to have three rectangles to make up the three sides of the triangular based prism. Two triangles, three rectangles. Hopefully you're seeing a bit of a pattern, and you could now have a go at doing this for any based prism. I've got a complicated looking one here. It's got five sides. Five sides, so it's a pentagonal based prism or pentagonal prism. And if you were to draw the net of that one, You might like to pause and have a go at drawing it now for yourself. If you've had a go, this is what you should have, something like this. Two pentagons, which will be the front and the back face. And the rectangles will be 5 to make up the 5 sides of the pentagon. Just checking, I've got 5 sides on my pentagon. 1, 2, 3, 4, 5. Okay, an example of where we might use this with our maths. What we're going to be asked to do is find the total surface area of a shape. Now remember, we use TSA for total surface area. And I'm going to give you 2 different methods. You can choose whichever method you like, whichever method that works for you when you're doing your own working. So the first method, we'll be using the rule that the opposite faces are equal. So remember at the start, here's our picture we're looking at. Remember at the start we said this back face and this front face would be the same. This left hand side and the right hand side would be the same. And the top and the bottom would be the same. Now they're not all the same as each other, but they're the same in pairs. So we can use that. We need to start with TSA to show we're trying to find total surface area. Equals 2 times the front. So 2 times this side. Plus 2 times the sides, these sides, plus 2 times the top. So it would be the top and the bottom. Substitute our values in. The area of the front one is just 2 times 1. I'm just putting it in brackets here to make it clearer for you. Plus 2 times the area of the sides, so that's 3 times 1, because there's a 1 over here. Plus 2 times the area of the top. We've got this side, which is 2, and this side, which is 3. 2 times 3. And when you work that out, you end up with 22. Now, I've put centimetres because there's centimetres here, and I've used square units because it's area. It's total surface area, but it's still area. It's not length, it's not volume, it's area. So make sure you use square units when you are finding total surface area. That's our method 1. Second method is to draw a net and add up the areas of each face. And you might find that this one works a bit better for you and you can see it a bit more clearly. It's completely up to you which one you use. So, I'm going to start with my top side. When you label your net, you need to put the measurements on it. This is a 2, 2, 3. There should be 4 rectangles. 3, 1, 2, 3, 4. And another little. It looks like it's not a square really. This should look more like a rectangle. It doesn't matter as long as you've got the right measurements on there. So that's a 1. That's a 1. This is a 2, this is a 3. Some people can visualize this really easily and kind of unwrap this box in their mind to look at the net and label each of the sides. Some people find it more difficult and might enjoy having a look at method 1. What I'm going to do once I've got my net and all of the sides labelled, I'm going to just put a letter onto each face to help me show you where the working comes from. And then I can use this formula. Total surface area will equal the area of A plus the area of B plus C plus D plus E plus F. Area of A is 1 times 3. Area of B is 1 times 2. C is 2 times 3. D is 1 times 2. Oh, there's a little plus in there. E, 3 times 1. F, will I fit it in? 3 times 2. Just. Again, you don't have to have the brackets in there. I've just put them in there to help you see clearly what I'm talking about. When you work this one out, you end up with 22. It's still centimetres. Because we're doing total surface area, it's going to be square units, which is exactly the same solution we came up with up here, as you'd expect. Either method is fine.